And now, prepare to be inspired as we explore the world of motorcycle excellence with PMF, Polimi Motorcycle Factory. Led by Giovanni Frigerio, Mechanical Technical Director, alongside Andrea Alessandri and Matteo Galbusera from the Dynamics and Simulation Department, this racing team is revolutionizing motorcycle design. Discover how they harness the power of VI-grade solutions to accelerate towards excellence, from comparative analysis to component sizing.
Good morning, everyone. I'm sorry I'm not really used to talk in front of a crowd, but I will try to do my best. And oh, thank you. We are a Polimi Motorcycle Factory, and I'm just here to briefly present our project, and then the hard part of the presentation will be led by Andrea and Matteo. And so we basically designed, like Unimay University, we participate in Moto Student, which is a world competition made for students to build prototypes like ours, Stuka and Tatanka, our petrol bike and our electric bike. And in the middle of the room, there's our electric prototype that actually is the Vice World Champion of the last season of Moto Student in 2023. And we are now working on the next prototypes for the next season. So that's something about the team. We are Polimi Motorcycle Factory, and we work in Politecnico di Milano. And in 2018, we won the championship, the championship with the petrol prototype. She was called Shigeru, and our in 2021, we arrived in Moto Student with our first electric prototype, Nix, and in 2023, we became the Vice World Champions with the tank over there. So Moto Student is I already told what Moto Student is a competition made for students and for universities, and it's divided into two parts, MS1 and MS2, and the MS1 is basically what we had to deliver to the competition in order to be evaluated with the industrial design and business plan. And in MS2, it's the funny part for us, because we meet all the other university in Aragón for the week for the racing week, and we are. It's really fun because we race wheel to wheel in a real competition, in a real race, and it's very emotional. And this is a render of our petrol prototype, and his name is Stuka. And he didn't perform as well as the electric prototype, unfortunately. But I mean, for me, it was the best-looking bike of the paddock. So I mean, it's something. And actually, it scored the second place in the design phase, and it was pretty good also in acceleration and gymkhana. I mean, it was a bit unfortunate during the race, during the week, but it is we had proofs that she is a very good bike, and it can perform well and be really fast. And she is Tatanka, the bike over there. Maybe later we can discuss, if you want, with everybody of some particular things that now Andrea and Matteo will show you.
Thanks, Giovanni. Moving on, I want to talk about innovation. Innovation for us is a paramount. We always try to exceed our limits in every single area, and this is why I would like to share with you some of our most recent technical innovations, starting from our chassis, which was a fully milled aluminum chassis. Then moving on to the swing arm, which we're really proud of. We mounted it on both our prototypes, and it was our very first carbon fiber swing arm, designed and manufactured also together with a partner. Then our petrol motorcycle featured a titanium exhaust system, as well as an airbox with dynamic intake, and a air intake pipe made of carbon fiber manufactured directly by us. Then for our electric prototype, we also custom designed our battery pack and its battery management system. Then both the bikes were featuring a dashboard and a data acquisition system, again, programmed in-house. Finally, our aerodynamics department worked on 2 active systems, one for the petrol bike and one for the electric. You can see the aero brake in the top left corner, and we also had you saw it in the render before, a DRS-like wing on the electric one. So in order for us to achieve all the results that we did in the last seasons, it's also important to have a solid organization, and I would like to share with you also the structure of a team for this reason. Starting from a faculty advisor from Politecnico di Milano. Then we have what we call the Gestione Sportiva, made up of a team leader, and then our technical director electric, our technical director mechanics Giovanni, and our head of aerodynamics. And then below them there are 5 technical departments: powertrain electric, powertrain petrol, chassis dynamics, and aerodynamics. But not only technical departments, we also have 2 very important departments, the business and the communication one, which take care of managing our finances, take care of our image, our social medias, which are, of course, as you know, it's very important nowadays. I want to now share with you what our development process looks like in a simplified timeline, which takes about 2 years. We start from a concept development. We usually reflect on past mistakes from our past editions. We set new targets, which of course is always to win. And then we move on to some preliminary design choices, which evolve naturally into the engineering design phase. This is where we take advantage of all our tools, finite element simulations, CFD, vehicle dynamic simulations, of course, and finalize the design of the 2 prototypes. We then move on to the manufacturing of the first components, and then put together the whole bike, do some static testing on the single components, and finally get on track where the fun bit starts, and we get to see the bike going around the circuits. This is what it looks like for an example, the swing arm again. We started from the requirement of losing weight, so we decided to go for carbon fiber. We developed a CAD model. We, of course, did some finite element simulations in order to verify the strength of the structure, manufactured the first prototype, as I said, together with a partner, and then did some static testing. You can see here we mounted some accelerometers on the swing arm in order to estimate the natural frequencies. We characterized it in frequency. And then, of course, as you can see, we finally put it on the track. This is what it looks like. So moving on, this is where the help of our partners, specifically VI-Grade, helps us in the development of the bikes. And I want to share with you the 2 main phases in which we take advantage of the softwares provided by VI-Grade. Specifically in the engineering design phase, where we run vehicle dynamic simulations in order to estimate loads, in order to estimate power consumption, and then with this data we can size mechanically the components or electrical components such as the battery pack. This is crucial for us. Also, we run simulations in order to compare different configurations and select the best one in order to be as fast as possible. Then we also plan on using these the softwares, the VI-BikeRealTime softwares, in the dynamic testing, in the on-track activities, in order to fine-tune the setup and extract the most performance that we can from our bikes. Let's go deeper now into what we do with VI-Grade. We are using the suite of applications which revolve around the BikeRealTime, as was said previously, explained very well previously. And you can see here a simulation, what it looks like, a vehicle dynamic simulation of our bike. We use a number of applications, again, via roads, in order to generate a circuit, layout, or maybe to do some testing. We can do a chicane or whatever may be necessary. With the VI-BikeRealTime, we generate a bike model. We'll see later more in detail. And then, of course, we run the simulations. The animator allows us to visualize the outputs, but also read all the outputs from the hundreds of channels that come out of the simulations. And the event builder allows us to generate VDF files and create events. And then the VI-tire and VI-tire limits are also very important for us. As you know, from vehicle dynamics, replicating correctly or as accurately as possible tire behavior is crucial. So we take advantage of those tools as much as we can. Today we will talk about the 3 key areas in which we are using VI-grade softwares. And these are the comparative and performance analysis. We will show you today how we create and build a reliable bike model. And we will also choose different configurations to compare and show you how that is very powerful for us. We will also talk about, again, loads estimation, the different kind of loads that we can extract from the simulations, which can be tire contact forces, spring forces, and so on, and how we use them, again, to size components. And finally, we will also show you how we take advantage of the integration with MATLAB and Simulink to create a custom model of a motorcycle, and we will share with you all the advantages that takes and that carries with it. And now Matteo will go deeper into this.
Thank you, Andrea. Now we're moving on, and we start showing you our working cycle in terms of simulations. Firstly, we develop a motorcycle model. We have many schemas among which we can select the desired one. And we have to insert a large amount of data in terms of inertia and geometrical properties of each part of the motorcycle. And obviously, this type of data can be collected directly from the CAD or through experimental tests. And after this phase, we can move on and generate the circuit we want to analyze. This is Cremona, for example. And in this phase, we are also able to create the optimal trajectory on which the lap time is simulated. And obviously, curves, irregularities, and different surfaces can all be simulated. And now we can perform the dynamic analysis. In this phase, we run a speed gen moto simulation in which we create the speed profile which is used as a target. And then we run a dynamic simulation in which all the forces and the outputs are extracted. And we have an amazing tool which is VI-Animator, in which we can see the results of our analysis. And we are also very interested in the output files, in particular in .mat, because we work a lot with MATLAB, and in this way we can explore hundreds of output channels. And the last phase of the analysis is the validation of the model. We develop our own telemetry software, and in this way we are able to compare the results of the simulation with the track acquired during track tests. And as you can see, we reach a good match between the theoretical simulation results and the track ones. And once we obtain a reliable model, we can also make some changes in the configuration and analyze and acquire a predictive power. And another useful feature is the possibility to load more than one analysis in VI-Animator. In this way, we have an immediate feedback about the effectiveness of one solution rather than another. And moving on, the loads estimation. We know that in the motorcycle development, obviously, all the components, mechanical components designed by us has to be as light and safe as possible, and the motorcycle has to face demanding loads during his life, both dynamic as well as a few static loads that comes from the regulation. Indeed, the motorcycle has to pass a series of press tests during the dynamic event in order to guarantee safety for the rider. And obviously, the estimation of these forces is fundamental for the sizing and the finite elemental analysis of all the components. And as already said, some of the loads comes directly from the regulation, and the other one are estimated through VI-grade. This is an example. We use finite elemental analysis of different with different steps in order to analyze a wide range of loading conditions. This is one of the steps of the analysis of our front end. In particular, we analyze the resistance of the whole assembly, but in particular also the resistance of our steering plate that you can see on the slide, and that are also mounted on the motorcycle behind you. This, talking about Simulink, we have developed a Simulink model starting from the VI shared database. We introduce our motor, suspension, and aerodynamic forces models. And the advantage of using Simulink is the possibility to run MATLAB scripts for running simulation iteratively and also in much quicker way. And the other advantage is the possibility to introduce a brand new subsystem user developed. For example, the aerodynamic forces are not, it's not possible to introduce the lift coefficient inside the VI-BikeRealTime application, but with an external subsystem, we can introduce also the lift forces in order to take in consideration the presence of the front wings in our motorcycle. And talking about aerodynamics, is fundamental to achieve competitiveness, obviously. And our aerodynamic department deeply investigates the behavior of the motorcycle in terms of aerodynamics, estimating lift and drag coefficients, but also studying new solutions like the air brake in the petrol prototype, and also in the front wings for the electric one. And obviously, after performing this type of analysis, we have to assess the reliability of the results. And we are lucky because we can carry out this phase thanks to the Politecnico di Milano wind tunnel. But we are working also to so that in the future it will be possible to test this type perform this type of test in the directly on track with pressure scanners. And that's how we and VI-grade are accelerating toward excellence. Thank you for listening.